If the Bluetooth module is installed on the robot, we will need to remove it so we can program the Arduino. Now we can connect the USB cable to Arduino to program it. Start a new Visuino project. Click on this down arrow to open the menu and select Add Shields. Expand the Elegoo category. Select Elegoo Robot V3 Shield. Click on this button to add the shield. Close the Shields editor. In the Properties, expand Shields, the Elegoo Robot Shield, then the motors. Set slope of 2 for run and stop on both motors. Expand the infrared remote. Select Elements and click on this period button to open the Elements editor. Select Decode Neck Arrows Remote element from the Neck Arrows digital remote and click on this button to add the element. Close the Elements editor. This will add pins for all 5 buttons in the arrow area of the remote. We'll use the first 4 pins to control the robot. Forward, back, left, and right arrows. To control the motors, we'll add 2 analog value components. In the search edit box of the components toolbar, type analog value. Select the analog value component and drop 2 of them in the design area. Place them at front of the motors. Select both of them and set initial value of 0.5. This will indicate the motors to be stopped by default. Connect the output of the first analog value to the input of the left motor. Connect the output of the second value to the input of the right motor. To change the value when a button is pressed, we'll add 4 state elements, 1 for each button. Click on this Tools button to open the Elements editor. Select Set Value State Element and click 4 times on this button to add 4 of them. Select the first element and set value of 1. This means that when this element is selected, the motor will go forward. Select the fourth element and also set value of 1. Close the Elements editor. The other elements will remain with the same value of 0. Click on the same button for the second analog value component. Again, select Set Value State and click 4 times on the button. Select the first element and set value of 1. Select the third element and set value of 1. Close the Elements editor. Click on this Out area to start connecting all of the pins at the same time. Hold the Shift button and move the mouse to the input of the first element of analog value 1. Then click there. This will connect all of the connections between the 4 pins. Since the 5th pin has no place to go, it will not be connected. Release the Shift key, move the mouse to the analog value 2 and click on its input. The 4 outputs for the 4 arrows will be connected to the 4 value state elements. Since we are not holding the shift key after the connection is done, Visuino will not keep trying to make further connections. By holding the shift key, you can connect one pin or multiple pins to more than one recipient. Click on this button to generate the Arduino code and open the Arduino IDE. Make sure that Arduino Genuino Uno is selected as board. Select the COM port where the robot is connected. Click on this button to compile and upload the code. If you receive error like this one, this means that the IR remote Arduino library is not installed. From the menu, select Sketch, Include Library, Manage Libraries. Search for IR Remote. Select the IR Remote library and click Install. Close the library manager. Now our code should compile and upload. The code is uploaded. The robot is ready, and now we can disconnect it from the USB and test it. Now I can drive the car by pressing the 4 buttons: forward, back, left, and right, making sure that I am pointing to the infrared receiver. Now we can take a look at the design to understand how it works. To make the design area bigger, we can close the serial terminal. The infrared receiver will decode the signals, and if one of the up, down, left or right buttons is pressed, the corresponding output will change from false to true. Each of the outputs controls the speeds of the two motors. Let's look at the forward up button. This button is connected to the first elements of the analog value components for the two motors. Normally, if none of the buttons are pressed, the two analog value components will send value of 0.5, which means that the motors will be stopped. The motor speeds are 0 backward, 0.5 stop, and 1 full forward. So everything is normalized between 0 backward and 1 forward, with 0.5 in the middle. When the first button is active, the set value state elements will change the outputs of the analog value components. Both of them are set to change the value to 1, which means that both motors will start running full speed forward. When the infrared receiver stops receiving the forward command, the set value state element will go to false and the analog value components will return to their default value of 0.5. The rest of the buttons work exactly the same way, except the back button will set the two motors to reverse, and the left and right buttons each will set one motor to reverse and the other motor to forward, and the opposite way for turning the other direction. So you have forward 1 1, back 0 0, left 0 1, and right 1 0. Finally, we have set some ramping up and down, start and stop for the two motors, so they will not suddenly start and stop, but will slowly increase and decrease their speed, taking 2 seconds to reach the full speed or full stop. This is the entire project and the explanation of how it works. Enjoy your robot!